If you think of the global trends today, where mining is probably on the wane in Europe and on the wane in North America, except for Canada, and in the southern hemisphere and in China and India, very strong. And we can all learn from each other as we go into the challenges of the future. And the challenges of the future, of course, are ever decreasing grades of ore. So the technologies we're going to need to extract the mineral from the ore body are going to be very demanding, and we can't do them in isolation. So working together is the key opportunity that the IMPC gives all the practitioners and researchers worldwide a regular opportunity.
Well, let me say the important developments in mineral processing during those years has been primarily, I would say, in comminution, larger mills, much larger mills, in flotation, more automation, more process control, and let me say new sensors. I'm sorry to say that there has been very few breakthrough innovations, so we are still waiting for them.
The Council established at the time of the Istanbul Congress 3 commissions, and the purpose of these commissions was that we felt as a council it was important for us to appreciate that we have an important role to play as a spokesbody for the world of minerals processing. We're not the only ones, but I think we have an important role to play. So we established 3 commissions. The one is the Sustainability Commission, which is headed by Roberto Villas-Boas from Brazil. The second one is an Education Commission, which is headed by Professor Jan Cellier from the Royal School of Mines in London. And the third one was looking at the whole discipline of minerals processing, which has been jointly headed by Robin Batterham and Rod Elvis from Australia.
So whether it's flotation, separating minerals by bubbling air through them, whether it's high pressure grinding rolls, or whatever the technique, what we find over time is a gradually changing scenario of things getting more efficient, machines getting larger and larger. There doesn't seem to be any stopping for that. And again, we keep coming to this combination of the researchers and the developers of the equipment talking with the people who use it, the people from industry, one informing the other on this long journey.
It's critical that we have the voice of industry very strong at the congresses, because it's critically important that the research community understands the challenges that the industry are facing. And of course there's always the debate about push and pull. Should the researchers be pushing industry, or should industry be pulling the researchers? I think it's a joint venture. So unless we hear the voice of industry helping us to understand the challenges they're facing. For example, we know globally the challenges the minerals processing industry is facing focus on energy and energy minimization, water utilization, generally resource utilization, the decreasing ores, the supply of highly qualified or appropriately qualified people for the industry, which is an educational challenge. So it's a joint venture, and it won't be, we cannot achieve the success we aspire to if we don't appreciate that there are 2 sides to this important coin. And I have no doubt if somebody from industry was sitting here, they would have exactly the same view.
The industry's been pretty slow on picking up on academic research. And I'm hoping that that's going to see a change, because the opportunities are very great.
For industry, it is critical that somebody or research institutions carry out some fundamental research, which should be 10 to 20 years ahead of industrial applications. Without this research, fundamental research, which is ahead of industrial applications, there will be no improvement and no continuity in this build-up of this development of new processes and so on.
You can turn almost anywhere in the world, and some aspect of mineral processing is being undertaken. But now we need to make sure that we understand where all the resources are and to pull them together to solve industrial problems. So I'm a strong proponent, actually, of bringing together industry and academia.
You know, research institutions do not today exist as a separate state-owned. It was, for example, in the time of Soviet Union. In Soviet Union, you had a lot of institutes, state-owned institutes, which were very important and very good, by the way. But this system disappeared entirely, and now in the system that we have, research is carried out at universities, practically only.
In many countries, industry is doing less R&D now and less development than what it did 20 years ago or 40 years ago. And in some ways this is a little surprising because the industry is very competitive. You compete on world markets. If you are producing something at a higher cost, somebody from another country will come in and undercut you. That's the nature of commodities, and most minerals are commodities. So it does surprise me a bit that we've seen some fall off in the support by companies for the research and development side.
You see, there is a controversy, very strong controversy today, because industry wants to support the projects which are very short term, 3 months, 5 months, 6 months, and so on. And during this time, they want us to solve something which they need today. This is not fundamental research.
You know, innovation is a function of challenge. Challenge is a function of urgency.
We have the technical expertise, but unfortunately we have a gap between R&D as well as industry, and that gap has to be bridged.
The IMPC can highlight what the advances are and perhaps get more interest from some of the companies to address at a fairly fundamental level. Because if we have had of order 100 years of development in how you grind material and then separate it, you mustn't expect that all of a sudden tomorrow there's going to be a breakthrough that's going to totally change.
South Africa has got reserves of about 90% of the world's platinum. That runs at about 3-4 grams per ton. That's 3 or 4 parts per million, and it's going to decrease, and we're going deeper underground. If I think of gold mining, we're now heading to the 5,000 meters underground. So that presents huge challenges. Now the question I ask you is, in 100, 200, 300 years time, when we still need these metals for fabrication and we can only recycle a certain amount, what technologies will we be able to use? What about remote control technologies? So we don't send people underground anymore. What about actually really recycling on our plants to make sure that in fact we get the last drop of each mineral?
I think in the future, looking at the future, we should have more robotic mining and mineral processing, which will also enable us to go deep into the ocean. And one day, now asteroids apparently can be extracted, but one day you saw the rover is moving on the Mars. So for extraterrestrial mining and mineral processing and deep ocean, I think that kind of approach is required. For that also you need to develop computational technology.
If you use computer, you can better optimize, you can simulate by optimization, you can a little bit improve the process. But if you really want to improve a lot, you have to develop new technology. And development of new technology requires understanding of the fundamentals which are involved. It's not enough to know how to use the computers.
Computational technology and nanotechnology has not been used much in mineral processing. One can conceive of using nanoparticles that are hydrophobic, that means water heating, as medium for extracting ores that have been treated with surfactants or naturally hydrophobic materials such as talc. So that is another area that should be included.
We've been very fortunate in the last, let's call it 15 years of developments that have occurred that have helped mineral processing a great deal. And a lot of this has happened because of information technology, new computers, faster computers that can allow us to make calculations that in the past we couldn't have made because of constraints on whatever kind of computing devices we had at the time. Now, as you'll hear at this conference, I'm sure several people talking about very powerful pieces of equipment. In fact, so-called high-performance computing, which is at a whole different level than computing has been up until the present time. And I think we're going to hear a great deal about the new things that are coming about as a result of this high-performance computing.
From my personal point of view, the future R&D is to make sure that each grain, even the smallest of the grains of value, are fully recovered. We should not say cost is going to be high, we might not be able to compete with this country, price. I think that makes no sense to me. As I said, agriculture is, so even if we don't immediately mine it, we'll keep it somewhere. So by producing those grains, we need a very efficient grinding systems, energy efficient, existing machines. So this is where a major breakthrough is badly needed in terms of in this mineral processing industry.
Yes, of course, crushing and grinding has been around for a long time. You can read about it in ancient writings and so forth, going back for thousands of years. But the advances that have occurred are what makes a difference today. And we're in fact looking at new devices, totally different devices, not crushing devices, not grinding devices, but things that are in between, which are of very high efficiency. And currently it looks as if improvements on the order of 30 to 40% in efficiency have become possible in the last decade or so and have been proven in the industry, so that we will see more and more of these efficient devices being used.
Many parts of the world, mines are located in very dry areas. So for example, if I think of Chile, the importance of developing technologies where you can use seawater, or you can economically desalinate the seawater for processed water. So that's a typical example of an important challenge.
I would like to see mineral plants where, one unit operation I can do with two kinds of equipment. Let's say one is flotation, other is spirals. Flotation requires huge amount of water. Spiral requires limited amount of water. I would like to see all the development in the spiral to the extent that most of the operation that I do in water guzzling flotation circuits is done. So I would like to see water parsimonious plant design, new designs of, this is where I say we have to get up to a different level altogether.
I think one of the interesting challenges that we'll be facing in the next decades will be countries starting to protect their resources. For example, China recently declared an embargo on the export of any rare earth minerals because they are so worried about losing the control of the supply they've got. In South Africa, for example, high-grade coal for metallurgical purposes is a precious commodity. So we can keep on exporting to India and China, but there comes a point where you may start saying, let's look after our own backyard. It's very controversial whether one should be thinking that way. We've exported platinum all the years that we've been mining platinum since the beginning of the 20th century. Do we ever get to a point where we say, well, hold it a second, maybe we should stockpile? So how countries are going to manage this from a geopolitical point of view may be quite interesting in the future.
One of the difficulties with mining on a large scale, that simply opening a mine up and bringing the material to the surface is becoming so costly and so time-consuming that people are starting to think of other ways of going about it. And interestingly, to go into a mine and to have, if you like, multiple small mines is quite an interesting concept, with each one of them having its own much smaller, in-line, in-place mineral processing equipment. And this is a trend which I think the IMPC could pick up on and see some quite serious work done. It goes against the trend of equipment getting larger and larger and says actually there's also a place for equipment getting smaller and smaller and having multiple areas of operation.
And I am a believer that the nature always does it best. By that I mean, there are microbes which can exude enzymes which can interact with specific atoms only. For example, there is a Bacillus subtilis which will interact with gold. Gold is so rare in ores that it's very, very energy consuming and chemical consuming to extract. However, these bugs will go and complex only with gold. I call them ladybugs because ladies like gold, right? So essentially, these kind of microorganisms can be adapted to do selective mineral processing. Now, those are the kind of topics that we should address in the future.
Well, there are some who speculate on going into space, going into other planets and exploring there, and it's not a trivial idea. Some have thought about it. We don't know what resources are there, but there's still a lot of minerals underground still, and we've got to find them to start with. So the geologists play an important role. Process mineralogy, which is part of minerals processing. So yes, it's going to be with us for a long, long time. And the world will depend on the minerals processor for much longer than they may wish to think.